Shweta, what did we do alcohols के साथ?
We finished hydroboration oxidation.
Preparation by oxidation, right? So addition.
Yeah, the anti-Markovnikov one, like borane one.
What? Boring one.
Yeah, the borane one, bromine one.
Diborane. Yeah. Yeah. Okay. So preparation from alkenes, 3 methods. You want a regular Markovnikov product, you can just add water to it, acidic in the presence of an acid. So if you want, like if you don't want any rearrangement, but still you want a direct addition, go with oxymercuration, demercuration. And if you want an anti-Markovnikov, where you wanted OH to be added in the corner, go with hydroboration oxidation. Okay. Oh, Kaveri seems to have gotten disconnected. Okay, so that's all the methods where you get directly from alkene by adding HOH. The next set of preparations are from carbonyl compounds. Okay, so do you remember what carbonyl, like what would come under carbonyl compounds? What is this carbonyl group that we're talking about here? Sanskriti? Yeah. So what does carbonyl mean? What are we talking about?
Compound made up of carbon.
वो तो पूरा organic compounds ही है. What's this carbonyl NYL? So anybody else? Smera?
I'm not sure.
No?
I think there was one double bond with oxygen.
Yes, that's it. So compounds that contain this particular group, they are carbonyl like this is a carbonyl group. Okay. So when we say okay, this particular compound contains a carbonyl group, matlab okay, there is a C double bond O present. Okay. So two major ones that we'll like carbonyl ke saath we look at carboxyl also. So in this section we'll look at preparation from aldehydes, C double bond OH, ketones, C double bond O, and like 2R groups here. We'll also look at carboxylic acids, C double bond O OH, and esters, C double bond O, like O and R. Okay. So first set, aldehydes and ketones, they pretty much follow the same thing, just that because of the placement of C double bond O, we'll have like a different system. So if we want to prepare alcohols from these compounds, what do we need to do?
And what is it?
A double bond.
Smira, yeah, what were you saying?
No, Kaveri was asking.
What is the third one, ma'am?
Oh, carboxylic acid, C double bond OH, COH. Yeah. So aldehydes, ketones, say if we want to prepare an alcohol from this, what do you need to do? So let's say we had R, C double bond O, H, R, C double bond O, R dash. So दोनों के साथ एक ही method है. What rearrange, like what is the reagent you need to use so that you get alcohol मतलब क्या? So this should turn into R, C, यहाँ पे OH होना चाहिए. So what do you need to do?
Any proton source?
Close. Like it doesn't have to be proton, any hydrogen source. Okay. So
Proton is
proton is H plus. So it doesn't have to be a hydrogen ka cation. Okay. Any
so
hydrogen.
why when we do like substitution and all that we say instead of writing acids we often write any proton source, right? So how is that different?
It depends on the context, right? See here, if we want to convert this into an alcohol, we want to get rid of the double bond and add hydrogen on either side. So this is more of a reduction by direct hydrogenation process. So you add hydrogen in the presence of the same thing, platinum or palladium or nickel catalyst. Or instead of using a combination of this, you can also use NaBH4, like the usual direct reduction with hydrogen के लिए जो भी you use, same thing. Or you can use LiAlH4. Okay, so basically, all these cases, you're adding hydrogen across the double bond. So यहाँ पे this is what you get from aldehydes, and this is what you get from ketones. Okay. So with aldehydes, you always get primary alcohols. And with ketones, you always get secondary alcohols. And that's purely because of the structure where the oxygen is. Because oxygen is in the cornermost carbon, you'll end up with CH2OH primary alcohol. Ketone may it's in the middle of the chain, so you'll always end up with a secondary alcohol.
Is this the same thing that you were taught when you were doing oxidation last year? Okay, there were like aldehydes, ketones, and then acids.
ये reduction है उसका reverse. Yeah. So if you oxidize this, primary alcohols turns into aldehydes, secondary alcohols turn into, and reduction way, the same thing uska reverse. And so with aldehydes, pretty straightforward. You add hydrogen across the double bond. Sources of hydrogen, like reducing agents, either you can use direct hydrogen gas with metal catalyst, or you can use NaBH4, or you can use LiLH4 hydrides. Okay. Next set of reactions, we look at preparation from carboxylic acid and esters. So reduction of carboxylic acids or esters. Okay. So let me know when you guys have finished noting down and we'll start this. हो गया सबका? आर्यन? ठीक है. So carboxylic acid you have RCOH. इसको reduce करना है. Again, if you remember oxidation में, if you use a really strong oxidizing agent, or if you proceed with oxidizing aldehydes or ketones, you finally end up getting carboxylic acids, right? So here also the same thing, use a really strong reducing agent. In this case, use LiLH4 and do the acidic hydrolysis, H2O in the presence of H+. You end up with your primary alcohols. Okay, so the whole COH gets reduced into CH2OH. But this method is generally not preferred because this particular reagent LiAlH4 is quite expensive. So lithium aluminium hydride is expensive. This process becomes expensive as a result. So instead, what is usually done in the industry, like if at all you want to prepare alcohol from carboxylic acid, you first turn it into an ester. So do you guys remember how to convert acids into esters? I'm not sure if you studied that esterification reaction Tens made. No?
We-
Okay. So esters are prepared from the combination of alcohol and acid. So you make this particular carboxylic acid react with another alcohol. So let's say we do make it react with R-OH in the presence of H+. This turns into an ester. So the ester ka formula will be like this. So I'll just color code it so it's easier to follow. Hamesha esters matlab it's a combination of acid and alcohol, and the part that has C double bond O comes from the acid, and the part that's like OR dash comes from the alcohol. So if I use these two compounds, my ester is going to look like this: RCO, and alcohol say I get that OR dash. Okay, so this is my ester RCOOR dash. So this again reduction ke liye, instead of LiLH4, you use hydrogen in the presence of a specific catalyst. So usually if you're using esters, the catalyst used in this case is copper chromite. So give the formula. So CuO, CuCr2O4. So the name of this catalyst is copper chromite. So this will result in RCH2OH, same as what you would have gotten in the case of the acid, and your R-OH is also released, which you can like recycle it and feed it in this particular process.
Ma'am,
Hmm?
dumb question, but why do we have to write copper like twice? Couldn't it be just like CO2 or something?
That would be a simpler way of representing it, but this tells you that it's a complex salt. It is made of copper oxide and also this copper this salt.
So copper oxide by reacting with copper chromite, whatever.
No, it's just a complex salt. Like, so how complex salts are formed is like you have copper and chromite ions also, but also copper ions and oxide ions occupying some spaces. It's like how you find water of crystallization. Like a key structure mein you have both the salts there.
Or
It's because it's not completely bonded with the first like CO, right? It's not one whole compound as such. That's how
No,
complex
it's not
salts
a
are
whole,
made.
yeah, it's a mix of both these. Like you'll find all four ions in that in that solid structure. Yeah. So in the case of carbonyl compounds, both the cases reduction. If you're using aldehydes or ketones, it's like pretty straightforward. Hydrogenation using hydrogen gas metal catalyst, or any of the hydrides, sodium borohydride, lithium aluminium hydride, gives you that respective alcohol. When it comes to carboxylic acid or esters, like both are pretty much the same. Esters is a little roundabout that like industrially, because direct reduction of carboxylic acid is expensive, you first convert it into an ester and then uska hydrogenation say you get your alcohol back. The final product you get in both the cases would be the same same primary alcohol, whichever hydrocarbon part is connected to your C double bond O. So that part will give you your alcohol. Okay, so I'll give you some practice reactions to get so that you get the hang of this thing, so that you don't get confused which part of the ester is going to result in my alcohol. So because this is expensive, this is the commercial method of preparation. So this particular reaction from esters, commercial. So once you've noted down the standard reactions, let me know. Then we'll do a couple of examples based on this. Yes.
So what is that R dash OH?
So यहाँ पे, like, this is the ester, right? Formed from the acid part and the alcohol part, what we made it react here. So this bond basically breaks. Our alcohol is regenerated in the form of R-OH. We get this back. And this side of the compound, this side of the ester, which was the acid part of the ester, that gets reduced into another primary alcohol.
So first, when we add H plus, it forms RCOOR dash, and then again in the second step, when you react it with H2, is when you get the alcohol.
Yes. So this is the ester. This is the formation of the ester. So either you can take the ester directly, or if you want to avoid this cost, you have an acid to start with, you can convert that into the ester and then take this method.
So, but then an ester is formed in both the processes, right? Like even when we use Li, that the first thing that's formed is ester, and then again when you add H plus is when you get the alcohol, right?
इसके साथ ester, where is the other hydrocarbon part coming?
What? So then when is this? So then what is the second step for?
Step.
Like you said that in the first step.
So this is the first reaction. Step nahi. So this is, if you
So
start
then what's the 1 and 2?
an acid. Acha, this one.
Yeah.
Oh, this is a completely different, like you first treat it with the hydride and then you hydrolyze it to get your alcohol. Both these reagents pertain to this thing. Okay, if this is confusing, let me write it down like this.
There are two separate reactions.
Yeah.
That
So the second one, if we start off with an ester, so let's say we have, because direct reduction is expensive, you can take this, convert this into an ester by treating it with another alcohol in the presence of H plus. So this reaction, say we get an ester, which on reduction will give another primary alcohol.
Yeah.
Yeah, this is direct from carboxylic acid. This is from esters. Like if we were to convert the acid into an ester and then prepare alcohol from that. Okay.
No, I'm not. No, I'm saying that you've written in the first one. You've written first is like on the arrow. You've written first is lithium aluminum hydride, right?
Yeah.
And then we use H2, na?
Yeah.
So what is like the step? What are those two steps in which first we use lithium and then we use H2?
First, you have like a normal like hydrogenation reaction, and on hydrolysis, you end up getting an alcohol. Let me check the intermediate, like the exact mechanism for this. Okay. In the meantime, so I'll give you guys a couple of questions. First, So we have acetaldehyde. If we have to convert it into, or if I reduce it, then what is the product I get? Second question, I take B. On reduction, B is a ketone. And this on reduction with, let's say, LiAlH4 gives me so identify what B could be. Answer these two first. Yes, I got the first one. Kaveri got it. That is the first one. Sia, yes. Arya, yes. Smira got it. Yes. So put that in brackets, okay? Because if you, yeah, I get what you mean. But things that branch off, put it in brackets. That will make it more clear. Sanskriti, send the first one if you figured that out. Kaveri, complete the compound, no?
Don't consider that.
Okay. Sanskriti, have you figured out the first one?
Ma'am, I found the second one. I'm not sure about the first one.
So send the second one, no? Verify that, and once you're confident
But
about the first
I'll
one.
just send you in a second.
Okay. Sia, can you just give me the number of where that oxygen is supposed to be? Sanskriti, that is correct. Which, see, there are 4 of them there. Just give me the number. Sahi hai. Arya also got it. So Sanskriti, your second one is correct. So just work out the first one. If you got the second one, first one, बहुत like उससे ज़्यादा simple है वो, you should get it. Everyone's answered, no? Arya got it, Sia got it, Kaveri. No, Kaveri has not sent the full answer. Yeah, Sanskriti.
I'm not getting the second one.
You got the first one, no? उसका reverse ही है. So if OH is at this particular carbon, मतलब reduction यहाँ पे हुआ है. So ketone मतलब क्या? We need a C double bond O. कहाँ पे हो सकता है that C double bond O?
मतलब?
See, like reduction of C double bond O into alcohol is pretty straightforward. Just hydrogen is added. So if you want to get the reverse of it, remove the hydrogens from that place.
Oh,
That's it.
so CH3.
Huh.
How that possible? CH3. Oh, CH3 C double bond O CH2 CH3.
Correct. You were on the right track. That's why I thought by mistake enter press हुआ होगा to send.
Right for the other one.
Hey, Sanskriti, how come you stuck here when you worked this out? You're right. Just write it properly, no? So CH3, CHO मतलब C double bond O H. So यहाँ पे both the H's will get added. You get CH2 OH. That's it. I'm Riya.
Ma'am,
Huh.
for this question, they'll give, right, that it's a ketone.
Yeah. Yeah. Because if it is just LiLH4, actually thinking about it,
No, they don't have to give it's a ketone because we know it's a secondary
alcohol. Yes. So secondary alcohol.
So we won't get secondary by reduction of carboxylic acid.
No. So aldehydes and carboxylic acid also, COH is always at the end of the chain, right? So reduce करने पे you always end up with primary only. Okay, so in this case also both esters and this thing you get primary alcohols. Note it down. Okay, so look at the mechanism. So if you have COH, सबसे पहले deprotonation, you end up, huh?
You have to remember this.
No, you don't. Like, that's why, for your clarity, if you're curious, follow along. Otherwise, as long as you know that carboxylic acid say primary alcohol aayega, that is sufficient. Okay. So intermediate and all, like it gets a little complicated. So you can see there's LiLH4, say you have a lithium salt, aluminium hydride hoga. Now, aluminium is electron deficient. So nucleophilic attack by the hydride anion. H, like because hydrogen is bonded to metals, it exists as hydride. It's literally called lithium aluminium hydride. You can make a note of this if you want. So this particular reaction, you can, it's like every time there's addition through LiLH4, it's a nucleophilic addition reaction. So especially addition in the case of aldehydes and ketones. So if you're using LiLH4, because hydrogen exists as H minus, so in this case, it's a nucleophilic addition reaction. This is just in case you're asked competitive exam mein ya fir 1 marker that way.
This is only for aldehydes and ketones.
Yeah, because only here you have an addition reaction taking place where hydrogen is added on both sides, right? And here H exists as H minus, which get added to carbon, and then yeah, other stuff takes place during the mechanism. Okay, and yeah, continuing with this. So the salt, then same thing, nucleophilic addition, H gets added. The positive aluminium goes to the electron rich oxygen atom. You kind of get this complex. Then again, you can see this is quite unstable. Lots of things happening here. So this rearranges. You end up with an aldehyde group first, and then again one more step of reduction takes place, and then finally in like from the lithium salt, in order to convert it into an alcohol, the hydrogen takes like water acidic hydrolysis takes part in that step. Okay, one more question. So if I start with acetic acid, CH3COH, when it is reacted with isopropyl alcohol, in the presence of dilute sulfuric acid, gives me product AB हो गया C. C, it's a sweet smelling ester. Now this on reaction on hydrogenation with a catalyst, copper catalyst, or not copper metal, okay, fine. Copper chromite catalyst gives me another compound T along with isopropyl alcohol. So identify C and D.
What is the significance of sweet smelling?
So esters are supposed to be like they're known for their sweet, fruity smell. So the synthetic erasers, perfumes, things like that, they have esters added in them.
What is the sweet smell?
So like you
That's
have
very keto.
yeah. They have like all these scented stuff, right? Stationery and all. So that scent, that like weird, it's like it's a fruity smell, but you know it's not a real fruit. So that comes from esters.
Sweet smelling was something, I don't remember, but it was somewhere I read it in polyhalogen compounds also. What was that? They're
Many
like a
compounds can get sweet, like they can have different smells, sweet smelling, bad smelling. Like vinegar has that pungent smell. It's just one of the characteristics we use to describe it. But it is like number one thing about esters. Like you get introduced to esters, it's like yeah, used in soaps, perfumes. It's a sweet smelling thing. in case there's anyone stuck at this point. So isopropyl alcohol is CH3, CH, CH3. Sanskriti, yes, D is correct. C, intermediate क्या हो सकता है?
Is C correct, ma'am?
C, technically yes, but instead of saying C3H7, is it a straight chain? Like, is your C3H7 like this? CO के बाद? Oh no, C is not correct. Missed out on one thing. Missed out on a couple of things. Yes, Sia, C is correct. Kaveri, yes, but again, isomers exist for a reason, right? So, can you elaborate? Sijan ke baad. Use brackets for the branches.
Ah,
So, Sia got both C and D correct. Sanskriti got D. Need to work out C. Kaveri, I think you're almost there. You'll get D also easily. Smera, D is correct. C is not correct. Check again. Isopropyl alcohol is this. You used ethyl alcohol. So.
So, ma'am, instead of C3H7, what do you write?
Just write it like this, no? See, OH and H from here get eliminated. So you have CH3, COO. O is connected to CH. So यहाँ पे CH needs to be there. And then you have CH3 connected. So either you can put one CH3 in bracket or you can put both of them, make it twice.
It's CH3CO, right? How CH3COO?
CO, OCH3. Ester is just that.
Achao.
But then C3, CH32 would make it C2H6, right? So,
C2H6.
acha, wo CH is written separate.
So either you can write it like this or you can write CH3 in brackets and CH3. So that way CH है, फिर उसके बाद CH3 आएगा and this one is a branch. So either this or this. Sanskriti, you missed out one oxygen.
Yes, ma'am, I mistaken.
This where will be the CH3 wala branch be?
Where will it be, Matlab?
Which as in how would you write it if you were to write, yeah, with showing the double bonds in it?
Okay. So CH3 C double bond O, यहाँ तक acid से आ रहा है. Alcohol, when it reacts, oxygen आ रहा है. CH3.
CH3, yeah, okay.
This is that ester. So this part is what makes it an ester. You have C double bond O. Functional group.
Now is it correct?
And then for D, what happens?
D, what happens? The carboxylic acid. So this part alone is converted into an alcohol and this isopropyl alcohol is generated back. So that's another hint. Isopropyl alcohol aa gaya. So the remaining part, the CH3CO part, is converted into an alcohol. So D, CH3, CH2, yes. So the ester part, few of you got stumped, but most of you got the alcohol right. That's fine. So another easy way, like suppose you get question in this format, basically whatever acid you start off with, that gets converted into alcohol. That's one straightforward way of it. And even if you're given an ester, C double bond O pehle jo bhi hai, so this particular part gets converted into an alcohol. So you can ignore everything after this oxygen. That's regenerated as oxygen. Like don't completely ignore it, but yeah, you get both the sides. Okay, so this is all about reduction. So oxidation ho gaya from like alkenes. Then this is reduction. Okay, should we go to the next part? See, preparation from Grignard's reagent. You remember Grignard's reagent?
RMGX.
Yes. Okay. So where Grignard's reagent come into picture is use aldehydes or ketones plus your RMGX. So this takes place in two steps. The first product is an adduct. So adduct means it's just a fancy term for it's like it's the addition product between both of these. Don't worry about it. I'll take an example, start making sense. So this on hydrolysis, treated with water, you get alcohol plus MgOH. Okay. So for example, we will start with a simple thing. So suppose I have HCHO, formaldehyde. So iska, like I'll expand the structure. C double bond OH. This is the aldehyde plus RMGX. So identify the charges. Grignard reagent में it's pretty simple. Positive charge कहाँ पे होगा in Grignard's reagent?
R.
Huh?
Mg.
Metal. Always. Whenever you have a metal, that will always be positively charged.
But there's X also, right?
Huh?
So
Metals are always electropositive. You'll not find them with negative.
halogen also.
So minus and then minus.
Oh, I thought MGX had to be put together.
Yeah. So basically, ignore this. MgX will kind of stay together. So that's the speciality of Grignard reagent. You use Grignard reagent wherever you want to increase the hydrocarbon chain. Wherever you want to add R minus to an existing compound is when you kind of use Grignard's reagent. Or when if you take something like water or a very dilute acid, that H plus gets added to the R part, you get alkanes. So whenever you want a negatively charged hydrocarbon part, is kind of you prepare Grignard reagent. Okay, now on this side, where do you have like positive charge and negative charge in this compound?
This is a continuation of the previous thing, right? From
No, this
Carbox.
is Grignard's reagent.
This is also aldehydes and ketones also.
So that was mainly reduction of carbonyl compounds. We reduced aldehydes, ketones, we reduced carboxylic acids and all. Here pe using Grignard's reagent with aldehydes, ketones. Okay. So what is the charge distribution like in this case? Positive charge, negative charge kahan pe hoga?
Negative on O.
So this has like delta negative. This will have delta positive. Okay, so once you figured it out, you can easily get what is the adduct that will be formed. So opposite charges attract. So the R part gets added to this carbon and the Mg part gets added to the oxygen. Okay. So technically these electrons are attacking this, so it should be like this. So your adduct is going to look like you have C. This will become single bond OMGX, and this will be CH2, no hydrogens either ही है, and यहाँ पे the R is added. So it kind of look like this. So the R gets added to the C, the two hydrogens remain as it is, and the MgX get added to the oxygen.
Miss, what is that addition product that you put in the bracket?
So this is the addition product. It's called an adduct. So any product you get by adding, like, you know, you're literally combining, like you don't have any byproduct or anything, like both of these separate parts are added to one compound. So that sort of a product is called an adduct. Okay, so once you got this, the next step is hydrolysis. So hydrolyze करने पे you get R CH2 OH and MgOHs. So if you want a little more clarity, maintain the symmetry. So the H and H is to be there. Okay. So typically, this is the only way you can prepare all types of alcohols. So depending on what type of alcohol, you pick either the specific aldehyde or ketone, and you pick that Grignard reagent depending on how long of a carbon chain you want here. Okay, so if you want to prepare primary alcohols, you use formaldehyde, because यहाँ पे C is connected to H's, right? So you directly get CH2OH. If you want secondary alcohols, you use other aldehydes. And if you want tertiary alcohols, you use ketones. Okay, note this down, then we'll do an example in each case to see how that happens. So let me know when you guys have finished writing till here, then we'll do an example in each case.
Primary is primary alcohol.
So this is alcohols. So if you want primary alcohol, use this. Secondary के लिए this, tertiary के लिए this. Yes, let me know when you finish writing. We'll do examples.
I meant thousands.
Arya Sanskriti finished? Okay. So example 1. So basically this is overall predict the alcohol that you get. Okay. So first case, I'm taking methanol plus CH3 MgX MgCl. So what is the alcohol I get? Call it A. Second example, let's just ABCD use kariya na. This is X. Acetaldehyde CH3CHO ethanol plus CH3 MgCl gives me Y, and acetone CH3 CH3 plus
We have to give the final product, right?
alcohol. Predict the alcohol form. Um, yeah. So predict X, Y, and Z. Like all three of them are alcohols, so you need to predict what sort of alcohols they are. Yes, that is correct. So when you're noting this down, write down the whole mechanism. Like write down what is the adduct formed and then usse kya aayega. Okay, so that way the mechanism, like the steps also, you'll get used to it. So if you're asked that in a question, again, you won't face it. It'll be easier. Okay, but Kaveri X is correct, final product. That is it. Smera, can you use brackets? Because the second one is not, at least the way you've written it, it's not exactly correct. See, yeah, no, first one is not correct. Check again. कार्बन का बैलेंस ही फुलफिल नहीं हो रहा है.
For something to be secondary,
That is why instead of trying to figure out कैसे secondary होगा, work it out using the mechanism. उससे पता चलेगा and then you'll get the right answer also. So for ethanol, it's going to be CH3 C double bond OH. And figure out यहाँ पे CH3 कहाँ पे add होगा, MgCl कहाँ पे add होगा. And then work it out from there. आ जाएगा. Yeah, yes. I'm sure there's an easier way to write that, but yeah, I think like if you write down the structure, you have gotten the right answer. So this is Arya, yes. I'm assuming that's the first one, right? Huh. Sia, first one, yes. Kaveri, is that the first or second or which one? Second one, yes. Got that.
I mean, it's not very good.
Did you work it out on paper though?
I did, yeah.
Okay. Sanskriti, X is correct. One got it. So this will get added to C, this will get added to O. Each may you get.
So, ma'am, we can say that the जो भी R है, that is the one that's going to be twice, right? For the second day. I mean, like in this case, it was CH3. So, I mean,
So the point is,
I think of
Grignard
it.
के साथ you have an extra carbon getting bonded to the one that has oxygen. So when you have only hydrogens, you end up with primary CH2OH. When you have this carbon bonded to one carbon, because you're getting one extra one, primary in this case becomes secondary. And then यहाँ पे already secondary है, bonded to two carbons. So because this is getting added, this becomes tertiary.
This, in the first one, there was HCHO. So in that, in the intermediate, we wrote HCH, मतलब दोनों side पे one HH for this with the carbon, right?
This is the CH2.
So when there is a CH3, what would, मतलब, how would you write it? The intermediate.
Same thing. So we have CH3, C double bond to H, right? So now CH3
Yeah.
gets attached to this क्योंकि थोड़ा सा electropositive है. Oxygen is negative charge, this is positive charge. And this plus will get attracted to this minus.
Yeah.
So यहाँ पे basically C double bond O will become single bond O.
OMG.
H.
No, OMGCl, no?
This will be MgCl. And then this CH3 gets attached over here, CH3.
Yeah.
So Smera, there's an extra, I don't know if you've copied the compound wrong or something, but second one may kuch to issue hai. There's an extra carbon that you have there. Sanskriti, X is correct. CI, I got the second one. This on hydrolysis, you get MgCl will get replaced with H. So you get CH3.
C by mistake in front of OH.
Huh?
I typed the C by mistake in front of OH. वो CH2 bracket OH था.
ठीक है. That's right. Yes, yeah, I got the third also. Kaveri, yes, got the third one.
Is that the right way to write it?
Yeah, how do you write it?
Both of you have written it. That's fine. I'll write it once. Sanskriti, Y is wrong. Check, no, I've written it here. Compare it. Arya, the one that you just sent, is that Y or is that Z?
Why?
Check. सही नहीं है.
Yes, I didn't understand what's wrong.
So I've worked out the second one here. So you've gotten the intermediate यहाँ पे the adduct.
Yeah.
उसके बाद you just have to replace the MgCl with H. So what do you get? So यहाँ पे it's congested. I'll write it here. So we have CH3, C. CH3 was added. H was already there. This OMgCl would have become OH.
Yeah.
So what compound do you have? So if you write it properly, you have CH3, CH, OH, CH3, right?
Oh, I wrote the structure.
How would you write this in condensed form?
The way you guys have written is absolutely fine. You have CH3, CH, OH branch hai, to put that in bracket, then CH3.
Or we can put CH3 in branch.
Yeah, that's also fine. Like if you're going this way, then CH3 becomes branch. You can put that in bracket. Okay, so do the fourth one also. Like once you guys have got the hang of this one, Sia and Kaveri, both of you got it.
Ma'am, I'm not sure about the acetone one. How to?
Yes, Miss Adam.
Not sure about the product or not sure how to type it and write?
Both.
Both.
Okay. Okay, so I'll put it here, compare it. You want to try giving the IUPAC name for that?
No.
Why? Nomenclature तो पहले कर लिया ना. Try it. Do it.
IUPAC
No, but
को-
I don't understand only what to do. So then what? Kiska UPSC give?
Final was like the alcohol that you got. Uska IUPAC.
No, but I didn't get. No, that's Meragon.
Okay.
Yeah.
Okay. Like, did you get the mechanism of how to work this out?
Yeah, I got the aldehyde one, but like,
The
is
same
it
thing.
this? Is it similar for?
Yeah, yeah. It's the exact same thing. That's why the same thing for everything.
I got this. I sent you. once.
Smera, I think you got the right one, but IUPAC you messed up. Longest chain. And
Oh,
when
yeah.
you have two things attached to the same thing, that becomes based on what you considered, like longest chain you need to consider. Otherwise, yeah. Okay, so CH3, C double bond O CH3 plus C2H5 MgBr. So Arya, what goes to what? Like,
Yeah.
what's the next product?
You write CH3, C, and then with O you write MgBr,
Okay.
and again CH3. And where the plus sign is, there will be C2H5.
Connected to this carbon. Oh yeah. Then final alcohol क्या होगा?
Instead of MgBr, there will be H.
Yeah. So CH3, C, CH3, C2H5, OH.
Uske baad, how would you write it?
This is your final alcohol. So it's if you want to get the condensed formula, either you can go in order, like if you want to go by the longest chain thing, so you can write, you can either start off with C2H5 or you can just expand the CH3, CH2, C, CH. taken twice OH. This is one way to write it. So I went based on this chain and then treated, okay, ये दोनों branches है, ends with OH. The way Sia had sent in, like I kind of, and the way Kaveri had sent in, like I kind of figured out. So this is what Sia had done. Okay, you'd written C2H5. Kaveri, she basically took the central carbon and just treated everything as branches, put everything in brackets, and she wrote it. So I kind of got the hang of it, what she meant. So
that one is not right, no, but
see, for now that's okay. But when you're presenting, people are gonna look at the structure only mainly. So ensure that you get this, and that's fine. Okay, but otherwise, like mechanism, final alcohol product kya aana chahiye? You guys get the hang of it, or do you want to do a couple more?
Ma'am, I sent the IUPAC name for the last one. Is it correct?
Yeah. Yes. Okay. So do you want to do a couple more of this, or do you get the hang of it? Like products, like if you final product sahi tha, lekin expressing it was a problem, no issues. But getting here itself, if you aren't sure, then we'll do another question of this.
Miss, what's the IUPAC name?
Longest chain 4 carbon atoms. So second carbon पे alcohol है और methyl है. So 2-methyl butane to all.
2-methyl butane. Yeah.
Okay. Next, then so that's it for preparation of alcohols. We looked at addition of water. We looked at reduction of carbonyl compounds. Or compounds containing C double bond O, and then this was preparation with Grignard's reagent. So all of them have their pros and cons. Like if you want a specific alcohol, you can prepare it cheaply using the acid, because acetic acid and all are pretty readily available. You can go with that. But if you want the flexibility with Grignard's reagent, you can prepare any sort of alcohol, like primary, secondary, tertiary. You just have to choose the correct compound here, and you can get any structure you want with this. Okay. So next we come to preparation of phenols. So preparation of phenols, first one is a reaction that we had already done. So we can do it using haloarenes. Again, this is like a very rare reaction, it's not very common. So chlorobenzene, when you treat it with NaOH under specific conditions of temperature, pressure, so 623 Kelvin and really high pressure, kitna? 320 atmospheres, you get sodium phenoxide, sodium salt of the phenol, this thing. And this treated with dilute acid, you get phenol and NaCl.
This was like the only chemical property wala thing that we did of haloarenes, right?
Not chemical property, only nucleophilic substitution if you wanted OH in place of Cl. Yeah. Okay. Others are a little more standard. So you can start off with benzene sulfonic acid. You guys remember sulfonic acid functional group kaun sa hai? You're familiar with it, that I can tell you.
SO3H.
SO3, sorry.
Yeah.
CO3.
So how do you prepare benzene sulfonic acid? So if I start off with benzene,
Was it like H2SO4 or something?
Yes, really
And then-
concentrated H2SO4, also called oleum. Okay.
The fuming oleum, right?
Okay, and this will give you sulfonic acid, SO3H, electrophilic substitution. This treated with NaOH and acidic hydrolysis.
Okay, I found.
Yeah, acidic hydrolysis. Then this will give you phenol. Again, this is also very similar in that when you treat it with NaOH, you get sodium phenoxide, and on hydrolysis, you get phenol after that. Just note this name because it's pretty common. This is sodium phenoxide.
What is oleum?
Oleum is another name for sulfuric acid, concentrated sulfuric acid. Hmm?
You said was H2SO4 plus SO3. That's what we call oleum. Right?
Concentrated sulfuric acid. So H2SO4 literally is when you dissolve SO3 in water. So if you have like a really concentrated version of it that you have excess of SO3, that's H2SO4 plus SO3.
What was chromic acid or something like that, which had H2SO4 also in it? There was some acid ka mixture or something in some reaction. Don't you?
Chromic acid, dichromate mein. So that's H2CrO4, that's chromic acid.
Oleum is fuming sulfuric acid, right?
Really concentrated version of sulfuric acid, yeah.
So why are we writing it separate?
Now I'm just like, in case you're not familiar with what oleum is, I've
Oh,
written
oh.
it here. Yeah.
It's in brackets.
Yeah. So next, do you guys remember this one? Diazonium salt.
Yeah.
How do you prepare diazonium salt?
NaNO3 and HCl.
Yeah.
No.
Yeah, HCl.
Nitrate or nitrite?
NaNO2.
Sorry, yeah.
Nitrite, HCl, really cold conditions. Make it react with what? Amines. So with aniline, you get benzene diazonium salt. With NH.
Means?
Aniline is amine only. No?
Oh, acha, what do you, yeah, okay.
So what is the, okay, so let's write that also. So since we are talking about phenols here, take aniline. This is an amine, aromatic amine. Make it react with NaNO2, nitrite plus HCl in cold 0 to 5 degrees Celsius.
Ma'am,
Yeah.
regarding this, I had a question. It said there's a question in the question bank which is like defines anomers. So it said primary amine. So what is the difference? Aniline amine, primary amine.
So if you have NH2, that's a primary amine. Secondary amines are if you have multiple carbons connected to the nitrogen thing. So this
In
is
this state. Oh yeah, got it.
yeah. So something like CH3, NH, CH3. This is a secondary amine. And tertiary is if you don't have any hydrogens here and then this thing. This is a tertiary amine. So what, like, we specify primary amines because this particular reaction with the production of the diazonium salt, that occurs only with primary amines. So it's also a way to test, differentiate between primary versus secondary versus tertiary. So all of this will come across when we study about amines. So this is diazonium salt. So if you want chlorides, you make it react with that specific chloride thing. But if you want alcohol, you want to get rid of all of this, just get alcohol. Then you make it react with water, warm water specifically. You get phenol. Plus N2 gas as usual that escapes out. And this chlorine, we get HCl. So once you have the diazonium salt, depends on what you treat this with. Shake it with a little bit of warm water, you get phenol. Make it react with copper chloride, copper iodide, then you get that particular chloride or iodide, whatever you take. That way you can use this. Okay, right. Arya's Merasia guess finished. Right?
Just 1 minute.
Yeah.
Most of these reactions you're familiar with, like at least half of that. Production of oleum and then the haloarine one. All of organic chemistry is gonna go like this only. So when we talk about aldehyde, ketone, carboxylic acid, you have studied half of those reactions. This already. Okay.
Yes, Mr.
Clear. Finally, this is commercially the most important method of preparation of phenol. This is from cumene. Okay. So this is how, like, if at all you come across phenol in laboratories and all, this is the worldwide preparation method used in industries. Cumene is isopropyl benzene. So you have benzene and then you have an isopropyl group here. So this is cumene. Yeah. So this on atmospheric oxidation, like oxidation by just exposing it to atmospheric oxygen, this turns into a peroxide. So I have carbon, CH3, CH3. So in place of H, you get a peroxide group. Oxygen gets itself between carbon and hydrogen. So this is called cumene hydroperoxide. when this is treated with a dilute acid, you get phenol and isopropyl alcohol. Sorry, acetone, not isopropyl alcohol. And both of these are industrially important products. So, which is why this is preferred method commercially.
Yes, we can write cumene for IUPAC.
Yeah. Cumene is like the most common colloquial. Oh, you mean if they asked for IUPAC name of that compound, can you write cumene?
Yeah. Yeah.
No. IUPAC name will have its own thing, right? Like longest chain. In this case, benzene will be the parent, and then write the isopropyl part. 1 methyl, 1 ethyl. Yeah.
It's okay, they probably won't ask.
If they ask for IUPAC, it's definitely going to be something with a functional group. Cumene will be asked.
In cumene, hydroperoxide is what? Like, what is the formula?
So peroxide is when you have this sort of structure of oxygen. So hydroperoxide because one side is hydrogen.
Hydrogen. Acha.
But isn't that just carboxylic acid?
No,
COOH.
see, yeah, carboxylic acid is C double bond OH. It's not COOH in like one straight bond. Oh no.
This you studied in 11.
And we literally just discussed carboxylic acid के साथ reactions also here. So just as information like trivia, so this part of the process, it follows like a free radical mechanism. Yeah, so there's oxygen homolytic cleavage of the double bond into single bond, and that attacks the central carbon and it goes that way. Yeah. So because the reactant, so cumene also is prepared straightforward again from benzene and propene. And then after the final process also you get phenol and acetone, both of which are like preferred, like very widely used this thing, which is why this is preferred for worldwide production. Yeah. So these are all the preparation methods of alcohols and phenols, guys. So alcohols ke liye we saw 3 major types of reaction. So one was addition of water to alkenes, or oxidation of alkenes. Then Second was reduction of carbonyl compounds, aldehydes, ketones, carboxylic acids, esters. And the third was addition reaction with Grignard's reagent to aldehydes and ketones. And preparation of phenols, you can prepare them from haloarenes, the nucleophilic substitution, or you can convert it into benzene sulfonic acid and then convert that to phenol, or you can prepare diazonium salt and then convert that to phenol. The commercial method of preparation is from cumene, where you get acetone as a byproduct. Okay. Do some questions based on this or start with physical properties? Phenols, ethers, okay. So preparation of alcohols is done. And we have preparation of phenol, 7 questions. Okay.
The second compound is acetone, na?
This one.
दूसरा वाला CH3 या
Yeah. Preparation of alcohols, we'll do like 3-4 questions from that. And then we'll do preparation of phenol also. There's 7. We'll do 3-4 from that.
Are we doing questions or
Questions. So join this, guys. Eight, 2, 1, 5, 7, 9. Arya and Kavri, you guys joining?
I was in, but then yeah, one second.
Ready? Minor product of this reaction is, okay, so diborane and H2O2 peroxide. So
this itself looks like a major product.
so diborane ka property kya hai? Like what sort of addition product do you get? Markovnikov, anti-Markovnikov?
Anti-Markov.
तो उसमें मेजर प्रोडक्ट इज द एंटी मार्कोनिकोव एडिशन. यहाँ पे पूछा गया है माइनर प्रोडक्ट क्या है इसका. सो ऐड like follow Markovnikov rule, add the OH and you'll get the answer. And you need to add it in the correct place. Lots of double bonds here.
So Markovnikov is the minor.
Yes.
This is so confusing.
So addition matlab it should occur across alkene. So यहाँ पे alkene कौन सा है? You need to identify correctly.
The double bond, like the reactive site is where, like the.
That's what you need to figure out. That's the key in this. So look at all the double bonds. See which one is an alkene, which is not, which will not come under an alkene. Then you'll get it.
What is H2O2 slash OH minus?
That's the reagent. So when you use diborane, you get trialkyl borane, and then you treat it with peroxide, and you get the alcohol. Check your notes, guys. We have done all of this.
Notes में it's like, oh no, but we didn't write H2O2.
Hydroboration oxidation. So hydroboration part is addition of borane. The next part, oxidation part, happens with H2O2.
That's H2O and aqueous NaOH.
H2O2 होना चाहिए. Corrected. So it's peroxide and aqueous NaOH. Sanskriti, what happened? Minor product they asked for. So Markovnikov you need to follow. Arya and Sia have answered.
I'm not getting it.
No? Okay. So, okay, Smera, are you trying? Like, have you answered yet?
I'm also stuck. I don't know.
Okay. Guys, turn your notes, revise hydroboration oxidation में क्या हो रहा है? Like, what did you start off with? What is your final product? What have you written about it?
Alkene plus B2H6.
Hmm.
Dialkyl borane.
And
then again with H2O2 and aqueous NaOH gives sodium borate.
alcohol plus sodium borate, right? The main product is alcohol, preparation of alcohol. Now, where does the addition take place? Like Markovnikov, anti-Markovnikov, किस तरह का addition है? Anti-Markovnikov, right? Smera? Okay. So यहाँ पे because they asked for minor product, तो उसका opposite answer they're looking for. Major product is anti-Markovnikov, but because we're looking for minor, Markovnikov addition. Okay, where is this Markovnikov addition going to take place? So we have a ring here.
The one which is not part of the benzene.
It's something like this. Yeah. And then we have another ring here, like this. यहाँ पे एक isopropyl. ठीक है. So will there be addition on any of these double bonds?
No.
No, because alternating double bonds, this is basically an aromatic benzene structure. So this will not undergo any addition reaction, which means this is the only alkene part that's going to have the addition taking place. Now, based on Markovnikov rule, so if I have to add H and OH, which will go where?
Based on Markovnikov. H will go
So
to.
I'll number this 1 and 2. So H and OH, where will they go? 1 and 2.
H will go to 1.
1.
Why?
Because that's attached to the
Most hydrogen carbon.
So how many hydrogens is this carbon attached to?
Oh, like that. Yeah, okay.
4 carbons. So this has 0 hydrogen. And how many hydrogens does this carbon have?
1.
1, 2, 3. Matlab, it has like 1 hydrogen.
Yeah.
Matlab, hydrogen will go to which carbon? The first or second?
Second.
More number of hydrogens. Which means OH kahan pe jayega?
First.
Yeah.
First.
So my final product is gonna look like this. So यहाँ पे OH होगा and यहाँ पे, so the double bond will not be there because that broke. So this will be my alcohol that I get. Yeah, so check, compare with the options and you'll get it. Yeah. So don't get intimidated by, like, wow, so many rings, so many carbons. It's all based on the principles that you learned. Like, just look at the reagent. pH3 taken twice, that's basically B2H6. Diborane matlab addition for alkenes. So see which alkene is it gonna get added to, and then use the principles like jo bhi reaction hai. Okay. Okay.
In Markovnikov, the hydrogen goes towards the lesser number of hydrogen. Na?
No. Markovnikov, it goes to wherever more hydrogens are there. Anti-Markovnikov mein it's the opposite.
No, the hydrogen I'm saying.
Mm.
The hydrogen will go where there are more hydrogens in Markovnikov.
In Markovnikov, no.
Hmm.
But then here you put hydrogen where there are where you put OH उधर hydrogen है ही नहीं ना.
हाँ.
So there come
Yeah.
hydrogen.
इधर है ना. So more number
But
of.
this is anti-Markovnikov.
No, this
This
is
is
Minor product.
Huh?
How did you answer?
Minor product. Major will be
Oh
anti.
yeah. Sorry. Ha, question.
It
It was, yeah.
Next. Identify the correct reaction. Guys, is the image reactions loading for you?
No.
Android? We'll skip this question if it's not. No?
Did you see? I'm on the same.
Yeah, this you should be able to answer. Preparation of monohydric alcohols by hydroboration oxidation method. Diborane acts as.
I can't see the question.
It will load. Still not?
I can see the question. It's there in Android.
Wait, I'll rejoin.
I'm still confused. Just by looking at a reaction, how can you tell if it's electrophilic or nucleophilic?
So what yeah, so you have to decide between electrophile, nucleophile only basically. 3 people have answered. So diborane is, it's attacking a double bond, right? So also knowing like we had discussed earlier, like the structure of diborane, we have B2H6 is a combination of 2 BH3. Like you guys also had this doubt ki borane iska valency is 3, like how can it form B2H6 and all, we had that discussion. So borane being electron deficient will act as an electrophile. That's why it's attracted towards the electron rich double bond between carbons. Okay. So diborane is an electrophile.
So something has lone pairs, can we conclude that it is electrophile or nucleophile?
हाँ, lone pairs हो तो it'll be a nucleophile, no? उसके पास बहुत सारे electrons है. It'll be attracted to electron deficient this thing like nucleus.
But how is a double bond? Okay.
There is no, yeah, so like boron doesn't have any electron pairs, like it is electron deficient because of that incomplete p orbital and all. That is why it dimerizes and like exists.
That's why it's a Lewis acid, no?
Yeah. Lewis acid matlab naturally electron deficient, and so yeah, that's an electrophile. Not correct about hydroboration oxidation of aldehydes. After this question, we'll switch to preparation of phenols.
In the first statement, by product, do they mean major product?
Yeah, major product.
No, sorry, the first statement is major or minor product?
Major, always major. Like when it's not specified, by default considered major.
It's
Ma'am, can you explain the second?
Okay, first is product is anti-Markovnikov. The nucleophile is attached to a more substituted carbon of the double bond.
how is it a nucleophile? Because we just saw there was an electrophilic substitution.
OH.
Yeah,
OH.
OH is the
Final
nucleophile.
product.
more substituted meaning.
So जिसके पास ज़्यादा carbons है. So if I have C and C and then H and C, this is more substituted. So it's another way of saying the carbon that contains lesser number of hydrogens. Arya, Smera, Kaveri, what happened, you guys? Second statement only you got confused.
I thought I was like, I followed Markovnikov. So
I thought nucleophile is attached to more substituted one. Matlab, when we did the example, the CH2, matlab, the OH was attached to the CH2, which is basically the more substituted of the double bond. So I thought, I don't know what I thought.
So if I have CH double bond CH2,
More substituted means it has more hydrogen.
more number of hydrogens are substituted. More substituted means lesser.
carbons.
Acha, ulta I thought, that's why.
Substituted hai na? So like hydrocarbon mein the hydrogen has been substituted by other things, like in this case hydrocarbons, alkyl groups. So more substituted matlab less hydrogens. Yeah. Sanskriti, Sia got it. That's why like Sia was clever, like, she got it clarified, more substituted and then answered. Okay. We'll end the session here.
That's not clever, that's cheating.
Okay, we'll look at preparation of phenols. Seven, 4, 8, 8, 6, 3. We'll do 3 questions. This shows till level 3. Okay.
I can't see anything in this.
No, we switched this thing.
It threw me out of the line.
No, it's still online. I can see your name here.
It's asking for the thing. Okay.
Oh,
Same.
join 748863.
This question is so simple.
Yeah. So answer no. Sanskriti, Arya, and Sia. You guys were mentioning about you rejoining, na?
Yeah.
What is sodium benzene sulfonate?
Sodium benzene sulfonate is like you prepared benzene sulfonic acid, right? Make it react with sodium or sodium hydroxide, you get the sodium salt of it.
Or is it the SO3H1?
Why doesn't it show the solution though?
Just one word.
No, but still, like the
Reaction.
mechanism of
Yeah.
yeah, the reaction. Does it show for you, Kaveri?
Okay. All five have answered. Okay. Next.
You think? What method?
This we haven't done it, right?
No.
This okay, this is not where the source is from. Yeah, this you should be able to do.
What is the difference between atmospheric oxidation and oxidation?
So atmospheric oxidation is explicitly exposed to the atmosphere. Oxygen gas from the air oxidizes it. If you don't specify that, it could mean oxidation using KMNO4, for example, or dichromate. Could be any way.
Hydrolysis is like water and hydration is just H2.
Hydrogenation is H2, hydrolysis is water.
And then what is hydration?
Hydration is addition of water, yes.
And what's the difference? I gave answer oxidation followed by hydration. How
Hydration
is it?
Addition of water. Hydrolysis is when you use water to break some bonds and put something else in its place.
Lysis means breaking, lysis.
So we just want H plus from that.
Either H plus or OH minus, but yeah, like a component of water takes the place of something else. Arya, have you answered yet or?
No, I haven't.
Hey, what is taking time? Like you already got it.
Yeah,
So atmospheric oxygen, which is why we use that O2 closer to air, followed by hydrolysis. Hydration is addition of a water molecule. Like alkenes ke method mein, that's hydration. Hydrolysis is like whatever you did like everywhere else, H2O in the presence of H plus. You have acidic hydrolysis, basic hydrolysis, all of that.
Miss, can you write the reaction for this one?
This is that cumene wala thing. So 2-phenyl propane, they're indirectly
Yeah.
saying use cumene. Oh, it's right here. So 2-phenyl propane hai, cumene. So this is atmospheric oxidation, like O2 gas from the atmosphere, followed by hydrolysis, specifically acidic hydrolysis.
Okay.
Sanskriti, you also got confused between hydrolysis and hydration.
Yes, ma'am.
Yeah. Next.
Basic medium means
Yeah, how do we know if oxidation is carried out in basic medium?
and when they say oxidation, like in the previous question was atmospheric oxidation. Does that have anything to do with the basic thing?
No, like atmospheric oxidation doesn't really have to do anything with basic. But yeah, I'll tell you, like, because this was not mentioned earlier, oxidation is carried out in basic medium. Like that is not the answer. That is like a true statement.
Okay.
Like always oxidation is carried out in basic medium or like in this
This
particular?
particular process.
But like what's the significance of that? Like उससे क्या फर्क पड़ता है?
So the next part of the process, right? Where is it?
That's an acidic now because H plus.
So if you don't like if you use acid, you don't want that to interfere with the production of cumene hydroperoxide with the
It's like to make it neutral, like basically. Because बाद में acidic है, like that.
So what happens is the H plus basically attacks this hydrogen. One of this gets removed as water, and that's how the mechanism proceeds. Like after the step, reduction into phenol and acetone. So if you have any other acid in the mix, if you do it in like an acidic medium, you don't want this to be disturbed. Like you want this to proceed in this particular way to produce phenol and acetone. So you ensure, you use basic medium to prevent any other reaction that may take place because of the addition of the acid. So this.
But okay, but what do you do to keep like a basic medium? Like we say acidic, तब we say ना कि इधर कोई acid like H plus or something is there. So when you, yeah, what are the conditions basically?
So that I'll have to look into. Like, let me see. I'll end the session here. Rest of it, you guys do it. So I'm not able to okay, so this undergoes a free radical mechanism. I'm not able to find a direct thing of what are the other conditions for this thing. Only the mechanism is directly given here. So I'll look into it. I'll send the link to you guys once I have found that. Yeah. So then we'll discuss the physical properties of E. We'll discuss as much as we can. Pretty simple, should be able to do it. And chemical reactions will start tomorrow. Okay. So physical properties. The usual appearance, solubility, density, boiling, melting points. Abhi density we don't discuss in this. That's the normal usual thing. But yeah, appearance, physical state क्या है? Solid, liquid, gas.
Of what?
Of alcohols. Alcohols. We'll start with
Liquid.
alcohols.
Liquid.
Yes. The smaller ones, again, it follows the same pattern as your alkanes, alkenes, everything else. So the lower alcohols are all liquids. So when I say lower alcohol, something like C1 to C5, C6, wahan tak. So smaller is the alcohol. Yeah. So they are all liquids. Specifically, they are colorless liquids. They look basically like water only. They have a distinct, they have a characteristic smell. They are not odorless. And
Sorry, but the one that is easily available is what alcohol?
ethyl alcohol.
Oh.
Burning taste. Yeah. Then the higher alcohol, so that's C2H5OH, ethyl alcohol. And the higher alcohols, as the number of carbon atoms increases, they tend to be like waxy solids because they're much bigger. Then they are also colorless, yes. But they are also odorless. The lower ones, they have like some sort of a smell. The higher ones, they're odorless.
What about taste?
Odorless matlab like that taste also is like can't really detect it. Tasteless. Smell and taste are pretty closely related to each other.
You can try and tell us.
I would
It's
not recommend that. Please do not try
No,
that.
I'm not interested.
And phenols, when we come to pure phenols, they should be colorless, but they start getting like a yellowish or reddish brownish tinge due to atmospheric oxidation. So again, this word atmospheric oxidation, just like keep the bottle open, keep it exposed to the atmosphere, reacts with oxygen here, and that's why the color changes. That's actually this thing. Yeah, once you guys have written it down, show you the visual. Okay. So pure phenol, colorless in the sense, if it's a liquid, it'll be like transparent liquid. Crystalline, like solid state, में you see that's white. But due to atmospheric oxidation, sorry, kind of turns into, it starts getting like a reddish brownish tinge. So if your phenol, like if you take a laboratory specimen, it looks like this, then this is not pure phenol. This is oxidized into something. Yeah, that's the difference. Phenol, like liquid. So this is all like oxidized stuff. Okay. Next. So this is all about
Phenol is phenol is solid or liquid?
liquid, but you can freeze it. Let me check. So you like
Because like the image you showed right now is like crystalline.
so melting point of phenol is about 40 degrees Celsius, close to room temperature. So you can get, that's why it's written as liquids and solids. Okay. I wanted to ask you before we go to boiling point, solubility and all, if we compare like, so alkanes, alkenes, alkynes, the lower ones happen to be gases, even in the case of, no, not in the case of alkenes, yeah. But if we come like for example, if you compare methane versus methanol or ethane versus ethanol, hydrocarbons are all gases, but here we started off with liquids. Why?
Could you repeat?
Yeah, could you repeat?
So if you compare a hydrocarbon versus an alcohol of comparable molecular masses, like ethane versus ethanol or methanol. So the lower hydrocarbons are all gases, but here the lower alcohols tend to be liquids. You don't find liquid gaseous alcohols easily. What is the reason?
Because of polarity.
Okay. What does that lead to?
Stronger bonds, like the electronegative oxygen will pull the electron. I don't know what I'm saying.
The
You're
difference.
Yeah, why does that
Edge
exist?
bonding?
Because of the, I don't know, I'm guessing molecular.
Yeah, heard
Edge
it.
bonding.
Edge
Yeah,
bond.
it's
said.
bond.
You didn't get the word. You were talking about stronger bonds, but why? What specific bonds are stronger? Edge bonding. So in alcohols, it's pretty straightforward edge bonding, not just the polarity, because you have oxygen which is connected to hydrogen, like highly electronegative atom connected to hydrogen. Remember, hydrogen bonding, you will find it in places where hydrogen is bonded to fluorine, oxygen, nitrogen, chlorine, like the top electronegative elements in the periodic table. Okay, that's one way of identifying it. Okay. Next, yeah, this directly relates to the next property we'll talk about, which is boiling point. So if you compare boiling point like a general trend of normal hydrocarbons versus alcohols, which one will have greater boiling points?
Alcohol would have greater boiling point.
Greater, yes. Okay, now comparing within alcohols, as the number of carbon atoms increases, what will happen to the boiling point?
That will also increase.
Boiling point, yes. Increased molecular mass will increase this thing. What about within isomers? As branching increases,
Will decrease.
yes, boiling point decreases. What is the reason for this? Do you remember?
More spherical, so
Reduce
the bonds are easier to break.
reduce surface area, which leads to weaker intermolecular forces. Okay, next. This is something that we discussed. So when you compare boiling points of normal alkanes versus, so ethers versus normal hydrocarbons, alcohols tend to have a higher boiling point than all of these due to hydrogen bonding. So
That's
relative,
the last class when we asked you ki why is it compared to water always? What did you say?
what?
You said like we compared phenols, alcohols, and water.
Yeah, because structurally they're all oxygen. So water may both connected to hydrogen. Alcohol, take one H, substitute it with an alkyl group, and ether, substitute both the hydrogens with the alkyl.
Ether, phenol, no.
Phenol is the same thing, na? Like alcohol hi hai wo, just that you have like aromatic compound here.
Could you go back to the previous slide 1 second? Yeah, done.
Here we are comparing it within whatever organic compounds we studied about. Ether, we haven't studied about it yet, but it's in this chapter. But usually compared to hydrocarbons, compared to alkyl halides, compared to ethers, alcohols tend to have a higher boiling point. And then comes solubility.
Miss,
Hmm?
in that statement, you've written RH, ROR, RX is lesser than alcohol in terms of boiling point. Like,
Yeah, all of this for boiling points.
no, but then is there any particular order between those three also, or like generally compared to all other hydrocarbons, alcohol will have the most boiling point?
Yeah.
No?
Within this also you can figure it out. See, if you compare alkanes, इसमें कोई भी polarity नहीं है, and also doesn't have like functional group. So this will have like the lowest generally. When you compare ether and RX,
X will be halogen, so more electronegative.
Yeah.
Na?
more electronegativity and also like slightly higher molecular mass. So you can like compare individually like that. Specific ones.
So boiling point would be less, na?
Iska?
For RX.
If I compare C2H5O C2H5, this will have a higher boiling point compared to C2H5Cl because its molecular mass is greater, C4. But if I take direct C4H H9Cl, then इसका greater होगा slightly.
But why isn't it easier to break halogens?
So halogen 1, see, C4 है, H9, C4H10, हाँ, C4H9, C4H9. Oxygen versus chlorine, chlorine has a greater molecular mass anyway, right?
What's the question?
No, if you were to compare individual boiling points. So you check, you take it,
That would
huh? What was that again, Kaveri?
would compare the total molecular mass.
That's what. You take it on a case by case basis, you compare the molecular masses, then you compare like the other things. Yeah. So again, this we are saying due to H bonding matlab, if you take all of these of comparable molecular masses where only the functional group is changing, alcohols tend to have the highest.
Ma'am, if we're asked to like give the order of boiling point or whatever, so which one would we give more priority to, the number of carbon atoms or the or like the branching? Because what if the carbon atoms are less and the branching is also less versus
First,
like
no. First you look at molecular masses. Then you look at the functional group. Like agar hydrogen bonding hai, matlab automatically greater boiling point. But if it's like all of them are alcohols, have like the same functional group, then you look at, you know, what are the isomers and how much is the branching and all of that.
Oh, that's last. Okay.
Okay. Next, solubility. So lower alcohols are generally like they are soluble. Generally, they are soluble. Again, because of H bonding that they form with water itself. Then as the hydrophobic part, like R increases, they're saying size of R increases, that makes more sense. Solubility decreases. Now, what can you say about branching? So as like in, suppose you have butanol, like two isomers of butanol, one is branched, one is straight chain. What will happen to the solubility as branching increases?
It'll increase.
Solubility will increase or decrease?
Increase.
Increase.
Increase is correct. Why?
Because when branching increases, the surface area decreases, so it will be easier to break the bond, so it will get dissolved more easily.
A little bit of fine tuning. So the surface area of the hydrophobic part decreases. So the repulsions basically decrease. So it will mix in water more easily.
Which one is the hydrophobic part?
Hydrocarbon part. So
I mean, but obviously, na, वही branch करेगा.
इसलिए like the size of that, but like that's why its size is decreasing, right? So the hydrophobicness decreases, which makes it more soluble. See, more hydrophobic means more insoluble, like less soluble. So as branching increases, you're reducing the size of the hydrophobic part. So that's why solubility increases.
How is it? How are you decreasing the, sorry, how are you decreasing the hydrophobic part? The number of carbon atoms are the same, no?
So I'll show you. So let's say we have CH3, CH2, CH2, CH2OH. So this whole thing is the hydrophobic part. If it is branched, CH3, 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 OH. So this is the hydrophobic part. Your logic is correct, like same as what's happening in case of boiling point, but because we are talking about solubility specifically, so rather than in terms of intermolecular forces, we talk about it in terms of, see, solubility matlab, how well is it mixing with water, right? How well is it interacting with the water molecules? So if the surface area of the hydrophobic part decreases, it means that it can interact with water better. Like,
Acha, so because the surface area is decreasing, the hydrophobic part is decreasing.
yeah. Yeah, so these are the physical properties we talk about. Chemical properties we will start tomorrow.
That's the last part, like chemical properties.
उसके बाद ethers हैं.